Graph of other trig functions. To graph a tangent function, a vertical asymptote is a line that the graph approaches but does not intersect. As x values get closer and closer to the line, the function value increases or decreases without a bound. The tangent function has a period of pi. So unlike sine and cosine, the period is 2 pi, tangent is pi. The domain is all real numbers except for odd multiples of pi over 2. The tangent function is undefined at x equals pi over 2. The range is from negative infinity to infinity. The period is pi. The graph is symmetric with respect to the origin, so the function is an odd function for all x in the domain. Tan of negative x is equal to negative tan of x. Its graph has no amplitude since there is no max and min. So to graph a y equals tan of x, we're looking at the first quadrant, which is from 0 to pi over 2. So at tan of 0, it's 0. At tan of pi over 6 is square root of 3 over 3. At tan of pi over 4, it's 1. Tan of pi over 3 is square root of 3. Then you can punch in other values, but you can go all the way to tan of pi over 2, and it's undefined. So notice that every pi over 2, the graph will be undefined. So there's a vertical asymptote at x equals pi over 2 and at x equals negative pi over 2. Once again, the characteristics for a tangent function is the period is pi, all real numbers except for odd multiples of pi over 2. The range is all real numbers. The vertical asymptote will occur at odd multiples of pi over 2. An x-intercept occurs midway between each pair of consecutive asymptotes, so halfway. Odd function with the origin symmetry. The points on the graph 1/4 and 3/4 away between the consecutive asymptotes have a y-coordinate of -1 and 1. So graphing y equals a tan of parentheses bx minus c, where b is greater than 0, we're going to find two consecutive asymptotes by finding an interval containing one period. And so when we graph tangent, we usually graph between the two asymptotes. So we're going to graph between negative pi over 2 and pi over 2. So what we do is, to solve that, we have bx minus c in the middle. So we're going to solve for x to figure out what the asymptotes are. We're going to identify the x-intercept midway between the consecutive asymptote. Find the point on the graph 1/4 and 3/4 away between the consecutive asymptote. These points have a y-coordinate of -a, whatever that a is, and positive a, respectively. And then we're going to use step 1, 2, and 3 to graph a full one-period function and add additional cycles to the left and the right as needed. So the first example, we're going to graph one complete cycle of y equals 3 tan of 2x. So we're going to identify the two consecutive asymptotes. We do this by finding the interval containing one period. So we have normally a period we're going to graph between negative pi over 2 and pi over 2. Well, in this case, we have 2x as my argument. And when I solve for x, I'm going to divide by 2. So when we solve this, we have that x is in between negative pi over 2 divided by 2 is negative pi over 4. And pi over 2 divided by 2 is pi over 4. So here my interval will be between negative pi over 4 and pi over 4, and that's where the asymptotes will be. So it will occur at x equals negative pi over 4 and at x equals pi over 4. Step 2, we're going to identify the x-intercept midway between the consecutive asymptote. So midway between x equals negative pi over 4 and x equals pi over 4 is going to be x equals 0. And x-intercept is 0 at the graph passes through 0, 0. Once again, you can also add the two x values, so it's negative pi over 4 plus 5 pi over 4, and we're going to divide by 2 because that's midway, and so it'll be 0 over 2, which is 0. So my x-intercept here is 0, 0. Step 3, we're going to find a point on the graph 1/4 and 3/4 away between the consecutive asymptote. Because a, the coefficient of the tangent in y equals 3 tan of 2x, is 3, these points have a y-coordinate of negative 3 and 3. So we know that this is going to be negative 3 and 3. So let's think about a number line. And we have a negative pi over 4. We have our 0. And then we have our pi over 4. So remember, 0 is in between those. So what we're going to do now is find a point in between negative pi over 4 and 0. And to do that, we're going to add negative pi over 4 plus 0 and divide by 2. So that's negative pi over 4 divided by 2 is negative pi over 8. So between negative pi over 4 and 0 is negative pi over 8. And between 0 and pi over 4, we're going to add 0 plus pi over 4 and divide by 2. That gives me pi over 4 divided by 2, which is pi over 8. So now we've found basically 1/4 away from the asymptote and then 3/4 away from the asymptote. And at negative pi over 8, it will be negative 3. And at pi over 8, it will be 3. So, and then at 0, we have 0, 0. And then we have our two asymptote, one at x equals pi over 4, and the other one at x equals negative pi over 4. So let's graph all that together. So I'm going to start with my x and y axis. So I have an asymptote at x equals negative pi over 4. I'm going to label that. And at x equals pi over 4. And then we have our 3 points, negative pi over 8, negative 3, 0, 0, and then pi over 8, 3. I'm going to label my x-axis. And we're going to connect our points. Example 2, we're going to graph y equals tan parentheses x minus pi over 3. We're going to find the two consecutive asymptote. Once again, we normally graph tangent from negative pi over 2 to pi over 2, and we're going to solve for x in the middle by adding pi over 3 Notice we do need a common denominator here, so negative pi over 2 plus pi over 3, the common denominator would be 6. So basically we have negative pi over 2 is equivalent to, if I multiply by 3, it's negative 3 pi over 6. And then pi over 3 is equivalent to, multiplying by 2, it will be equivalent to 2 pi. So negative 3 pi over 6 plus 2 pi over 6 will give me negative pi over 6. And pi over 2, once again, getting a common denominator, which is 3 pi over 6, plus pi over 3, getting a common denominator, which is 2 pi over 6. So 3 pi over 6 plus 2 pi over 6 is 5 pi over 6. So I have my two asymptote, and my interval here is between negative pi over 6 and 5 pi over 6. So my two asymptotes is x equals negative pi over 6 and x equals 5 pi over 6. So midway between those asymptote will be my x-intercept. So I'm going to add negative pi over 6 plus 5 pi over 6 and divide by 2, because midway means halfway. That's why we divide by 2. So we have 4 pi over 6 divided by 2 is 4 pi over 12. And when I simplify that, that's pi over 3. So my point will be at pi over 3, comma 0. That's where my x-intercept will be. So now we're going to find on the graph a 1/4 and 3/4 away from between the consecutive asymptote. The points have a y-coordinate of negative a and a. Well, here my understood a is 1. So it will be negative 1 and 1 respectively. So what we're going to do is, I have my little number line, think about a number line. And here my asymptotes was negative pi over 6 and 5 pi over 6. And halfway we already said was pi over 3. So now we need to find halfway between negative pi over 6 and pi over 3, and we're going to divide that by 2. Once again, we get a common denominator of 6, so I multiply pi over 3 by 2 over 2, which gives me negative pi over 6 plus 2 pi over 6 is pi over 6. Divided by 2 is pi over 12. And then we have pi over 3 plus 5 pi over 6. Once again, I'm going to get a common denominator by multiplying by 2. So that's 2 pi over 6 plus 5 pi over 6. And don't forget to divide by 2. So that's 7 pi over 6 divided by 2 is 7 pi over 12. So now we have our midway, a 1/4 and 3/4 away. So that other point, first point, will be pi over 12 comma negative 1. And my next point, 3/4 away from the asymptotes, will be 7 pi over 12 comma 1. So I'm going to start by labeling my y and x-axis. Now, notice here that I'm starting at negative pi over 6, but then I also have the points pi over 12, negative 1, and then 7 pi over 12, comma 1. So I kind of need to count by basically pi over 12s. So each space will be pi over 12, just so that way it's all aligned. So I'm going to start my first point at negative pi over 6, which is equivalent to negative 2 pi over 12. So I'm basically counting each space as pi over 12. So if I go on, the next space would be negative pi over 12. The next one would be 0. Then we have 1 pi over 12. Then 2 pi over 12. And I'm not simplifying my fractions. 3 pi over 12. 4 pi over 12. 5 pi over 12. 6 pi over 12. 7 pi over 12. 8 pi over 12. And technically, if you remember, 5 pi over 6 is equivalent to 10 pi over 12. So I'm going to continue this until I get to 10 pi over 12. So then we have 9 pi over 12 and then 10 pi over 12. And then my first point is going to be pi over 12, negative 1. My second point will be at 4 pi over 12, 0. And the reason why is because 4 pi over 12 is equivalent to pi over 3. And my next point will be at 7 pi over 12, 1. And then I have my two asymptote. My first asymptote is at x equals negative pi over 6. And my next one is at x equals 5 pi over 6 or 10 pi over 6. Remember, that's the same. I will connect my 3 dots, getting closer and closer to both axes. Graph of the cotangent function. The cotangent function, the characteristics is period is still pi. The domain is all real numbers except integrals multiple of pi. The range is all real numbers. The vertical asymptote will be all integrals multiple of pi. An x-intercept occurs midway between each pair of consecutive asymptotes. It's an odd function with origin symmetry. We're going to points on the graph 1/4 and 3/4 of the way between the consecutive asymptotes have y-coordinate of 1 and -1. Notice it's switched from the cotangent. It's going to be 1 and then -1 respectively. So here, once again, because the period is pi, this time we're going to graph from 0 to pi. So notice that here for graphing y equals a cotangent parentheses bx minus c, close parentheses where b is greater than 0, we find the two consecutive asymptote by finding the interval containing one full period. So bx minus c is between 0 and pi, once again because the period is pi. A pair of consecutive asymptote occurs where bx minus c equals 0 and bx minus c equals pi. I've just been solving the interval for x in the middle. Identify an x-intercept midway between the consecutive asymptote. Remember, you add the asymptote, divide by 2, and then we're going to find a point on 1/4 and 3/4 away. We'll use the number line to kind of make sure that we're basically adding and dividing by 2. And once again, the y-coordinate will be a and then -a respectively. And then we'll plot the 3 points and then the asymptotes. So example 3, we're going to graph y equals 3 cotangent of pi over 2x. So we have that this is going to be between 0 and pi over 2. X is less than pi. To solve this, we're going to multiply by 2 over pi. So we have that x is between 0 and 2. So here the interval is between 0 and 2. So we have an asymptote at x equals 0, and we have an asymptote at x equals 2. Now I need to identify the x-intercept. To find the x-intercept, we're going to add the two asymptote, which was 0 and 2, and we're going to divide by 2, and this will be my midway, so 2 over 2 is 1. So my x-intercept will be at 1, 0. That is midway, means halfway between x equals 0 and x equals 2. Now we're going to find a point 1/4 and 3/4 away. Well, remember, I've been drawing the number line, and this time it's going to be a and then -a. So in this case, a is 3, and then -a would be -3. So when we have, we're going to start with the asymptote being at x equals 0 and x equals 2. We said halfway was 1, 0. And now we're going to find basically halfway between 0 and 1. So 0 plus 1 divided by 2. So 1 over 2 is a half. So right here would be a half. And the point will be a half and a, which is 3. Then we're going to say 1 plus 2 over 2. We're always dividing by 2. So we're using the x-intercept and the asymptote and dividing by 2. So now we have 3 over 2, or 3 halves. And that's going to be -a. So that's going to be 3 halves, comma, -3. So graphing this, we're going to start with my x and y axis. I have two asymptote, one at x equals 0, which is right here, and at 2. So I'm counting by a half here. Notice I'm counting by halves. Okay, so my first point is going to be 1/2 3. My next one will be at 1 0. And my last one will be 3/2 -3. Example 4, we're going to graph y equals 5 cotangent of x plus pi over 4. Once again, for cotangent, it's going to be between 0, my argument, which is x plus pi over 4, to pi. We're going to solve this by subtracting pi over 4 on all three sides of the inequality. So we have negative pi over 4, getting a common denominator of 4, so pi would be equivalent to 4 pi over 4. So 4 pi over 4 minus pi over 4 will give me 3 pi over 4. So now we're going to find the x-intercept between the two asymptote. Well, here the asymptote is at x equals negative pi over 4 and x equals 3 pi over 4. And one period is between negative pi over 4 to 3 pi over 4. So to find the x-intercept, I'm going to add negative pi over 4 plus 3 pi over 4 and divide by 2, which is 2 pi over 4 divided by 2 will be 2 pi over 8, which simplifies to pi over 4. So we have our two asymptote. We're going to draw the number line, which is at negative pi over 4 and 3 pi over 4. And we said the halfway mark was pi over 4. So here the x-intercept is at pi over 4, comma 0. Now to find the points a fourth and 3/4 away, well, the first one would be negative pi over 4 plus pi over 4 divided by 2. So 0 divided by 2 is 0. So it's going to be the point 0, comma my a. Well, a here is 5. And to find the 3/4 away, we're going to do pi over 4 plus 3 pi over 4 divided by 2. So we have 4 pi over 4 divided by 2. Well, 4 pi over 4 is just pi, so that's going to be just pi over 2. So that's going to be pi over 2, comma negative a, so it would be negative 5. So here we're going to count by basically a fourth, or negative pi over 4. So each spacing will be negative pi over 4. So I'm going to start with the first one being at negative pi over 4. Remember, that's where our asymptote is. So we're counting by pi over 4. So we have negative pi over 4, 0, pi over 4. 2 pi over 4 is equivalent to pi over 2. And then we have 3 pi over 4. And then 4 pi over 4 would be pi if we need it. So my asymptote is at x equals negative pi over 4 and x equals 3 pi over 4. Then I have a point at 0, 5, so I'm going to extend my graph a little bit. My next point is at pi over 4, 0. And my last point is at pi over 2, negative 5. And I'm going to connect my graph. Notice this will get closer and closer to the asymptotes. Objective 3. Graph the cosecant and secant function. The graph of y equals cosecant and secant. We obtain the graph of the cosecant and secant curve by using the reciprocal identity. Cosecant of x equals 1 over sine of x, and secant of x equals 1 over cosine of x. We obtain the graph of cosecant by taking the reciprocal of the y values in the graph of y equals sine of x. The vertical asymptote of y equals cosecant of x occurs at the x-intercept of y equals sine of x. We obtain the graph of y equals secant of x by taking the reciprocal of the y values in the graph of cosine of x, and the vertical asymptote of y equals secant of x occurs at the x-intercepts of y equals cosine of x. So the graph of cosecant of x, the characteristics of that is the period is 2 pi, the domain is all real numbers except the integral multiples of pi, the range is all real numbers of y such that y is less than or equal to -1 or y is greater than or equal to 1. The vertical asymptote at the integral multiples of pi, and the odd function is cosecant of negative x is equal to negative cosecant of x with origin symmetry. So notice when we graph these, everywhere that the x-intercepts will be the vertical asymptote. For the secant, the vertical asymptote are at the odd multiples of pi over 2. Secant is an even function, so secant of negative x is equal to secant of x. The period is 2 pi. The domain of all real numbers except the odd multiples of pi over 2, and the range is all real numbers such that y is less than or equal to -1 or y is greater than or equal to 1. So we're going to graph y equals 2 secant of 2x. So first we're going to begin by graphing the reciprocal function, which is y equals 2 cosine of 2x. So now I'm working it like it's a cosine function. So we have the amplitude is the absolute value of 2, which is 2. We're going to identify the period, which is always going to be 2 pi divided by b. In this case, b is 2, so 2 pi over 2 is pi. There's no phase shift here, so now we'll find the values of x for the 5 key points. So we're always going to take the period divided by 4. So that's pi over 4. So the cosine function, basically the period in this case is pi. Since there's no phase shift, we're starting at 0. And then we have 0 plus pi over 4, which is pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4. I'm not simplifying right now. 2 pi over 4 plus pi over 4 is 3 pi over 4. And 3 pi over 4 plus pi over 4 is 4 pi over 4, or just pi. So now we're going to substitute it into y equals 2 cosine of 2x. And you can use the concept of my max, min, and my base, or the x-intercept, or you can just punch it in. It says 2 cosine of 2 times 0. Well, 2 cosine of 0, cosine of 0 is 1, and 2 times 1 is 2. Remember, we said that cosine starts at max and ends at max. In this case, it's going to start at 2 and end at 2. So it's going to be max x-intercept, which is 0. Then min, which is -2. And then back to 0, which is the x-intercept, and then max. Once again, we can punch these in, and you can verify it. So 2 cosine of 2 times pi over 4 should give you 0. 2 times cosine of 2 times 2 pi over 4 should give you -2. 2 cosine of 2 times 3 pi over 4 should give you 0. And 2 cosine of 2 times pi should give you 2. So here we're going to graph this. So I'm going to use a light blue color. And this is not my answer. This is just my cosine. So here's 0, 2, pi over 4, 0, 2 pi over 4, or basically pi over 2, -2, 3 pi over 4 is 0. Pi 2. So this is one period of the cosine function. Now, to do the secant function, we're going to basically, everywhere I see an x-intercept, I'm going to go ahead and draw my vertical asymptotes. So my x-intercept is at x equals pi over 4. And at x equals 3 pi over 4. And using the asymptote to guide us, we'll sketch the graph. So here, this point 0, 2 will get closer and closer to the asymptote. This point pi over 2 will get closer and closer to the asymptote. And the point 2 pi over 4 or pi over 2 comma negative 2 will stay between the two asymptotes. So the purple is actually the graph of this function. So example 6, we're going to graph y equals cosecant parentheses x plus pi over 4. So my guided function here is the reciprocal function of cosecant, which is sine. So we have y equals sine of x plus pi over 4. I'm going to rewrite this so that it's written as y equals sine of x minus a negative pi over 4, so it fits my format of y equals a sine of parentheses bx minus c format. So here I have my amplitude is the absolute value of 1, which is 1. My period is going to be 2 pi over b. Well, my b is 1 here, so it's 2 pi over 1, which is 2 pi. I do have a phase shift here, which is c over b. Well, my c here is negative pi over 4. My b is 1, so this is negative pi over 4. So I'm going left, pi over 4. My key points here is going to be the period divided by 4. So we have my period here was 2 pi over 4, which is pi over 2. So we're going to start left, pi over 4, and we're going to basically add pi over 2 each time, but because this already has a common denominator of 2 pi over 4, I'm going to use 2 pi over 4. So negative pi over 4 plus 2 pi over 4 is pi over 4. Pi over 4 plus 2 pi over 4 is 3 pi over 4. 3 pi over 4 plus 2 pi over 4 is 5 pi over 4. And 5 pi over 4 plus 2 pi over 4 is 7 pi over 4. And I'm going to stop there. We're going to check to make sure we did this right. So 7 pi over 4 minus a negative pi over 4 is 8 pi over 4, which is 2 pi. So that is my period, so I know I did this correctly. This is the sine function, so the sine function starts at the x-intercept or the base, then it goes to max, then it goes back to x-intercept, then it goes to min, and then back to x-intercept. So in this case, if you were to punch in negative pi over 4, we have sine of negative pi over 4 plus pi over 4. Well, we have sine of 0, which is indeed 0. Then we have sine of pi over 4 plus pi over 4. Well, that's 2 pi over 4 or pi over 2, and sine of pi over 2 is 1. Sine of 3 pi over 4 plus pi over 4 is 4 pi over 4, which is pi. Sine of pi is 0. Sine of 5 pi over 4 plus pi over 4 is 6 pi over 4 or 3 pi over 2, and sine of 3 pi over 2 is negative 1. And sine of 7 pi over 4 plus pi over 4 is 2 pi. So sine of 2 pi is 0. So notice my pattern was exactly correct. So I'm going to graph this, and I'm shifting over negative pi over 4. So I'm going to count by pi over 4. So each space, I'm going to let it be pi over 4 in between. So there's negative pi over 4, 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, just pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, and the last one will be 2 pi if I need it. So my first point here for the sine function, I'm going to use blue, negative pi over 4, 0. And then we have pi over 4, 1. Then we have 3 pi over 4, 0. Then we have 5 pi over 4, negative 1. And then we have 7 pi over 4, 0. So this is a sine function. Wherever there's an x intercept, that's where the asymptote is. So I have an asymptote at x equals negative pi over 4. I have another one at x equals 3 pi over 4. And I have another one at x equals 7 pi over 4. So I've already used 3 of the 5 points. And then I'm just going to use the asymptote to guide the function. So the point pi over 4 comma 1 basically gets closer and closer to the asymptote, kind of loops around. And the point 5 pi over 4 negative 1 does the same thing, kind of loops around, stays close and close to the asymptote. And so the purple is actually the cosecant of x plus pi over 4 graph. Graph of the sixth trig function is given here. So these are all the basic trig functions. Y equals sine of x, cosine of x, tangent of x, cotangent of x, y equals cosecant of x, and then y equals secant of x. So on example 7, we're determining the equation of the graph. Well, notice whenever we're doing the equation of the graph, we're always having 5 things. So I'm just going to kind of put a point on the 5 things. And so if you look at this graph, it starts at max, and the max is at 3. And it stops at max, which is 3. The min is at negative 3. And then we have our 2x-intercept, one at pi over 4 and the other one at 3 pi over 4. So we know that here this is the cosine graph. If you notice that it starts at max and ends at max, so we know that this is the y equals something cosine. Okay, we know the amplitude, or A, is 3 because of the max and min. Now, to figure out the period, we know that the cosine and sine both have a period of 2 pi. So normally it's always between 0 and x is between 0 and 2 pi. So we need to get it to be 0 on the left and 2 pi on the right. So this particular one goes from 0 to pi. So in order to get 2 pi, we're going to multiply everything by 2. So my argument here is 2x. On example 8, once again, I'm going to identify the 5 points first, starting at 0, 0. Oh, notice it went down to 0, negative 2. Then pi over 2, 0. And then it goes to 3 pi over 4, 2. And then pi, comma 0. Notice it goes to min first, which is at negative 2. Then it goes to the x-intercept. Then it goes to max, which is at 2. So this particular one looks like the sine function. because it goes x-intercept, min, x-intercept, max, x-intercept. We also know this is reverse, so has a negative and the amplitude is 2 because the order is reversed. The period here, so the normal period for cosine is between 0 and 2 pi, but this particular one is between 0 and pi. Once again, to solve, we need to multiply by 2, so we'll get the 2 pi that we want. So now it's between 0 and 2 pi, so my argument for this problem is 2x. So y equals negative 2 sine of 2x is the equation of the graph. Number 9, we're going to determine the equation of the graph. Notice that this is secant or cosecant. I don't know which one yet, but I'm going to use the red dashed to figure out which one it is. So notice that this particular graph, I'm just using the red, it starts at 0, 5, and then it's pi over 6, 0, then it's 5 pi over 3, negative 5, then it's 5 pi over 2, 0, and then it's 10 pi over 3, 5. So it starts at a max and ends at max. And I know that that function has to be the cosine function. What I also know was the amplitude was 5 because it's high 5 and low is negative 5. Now, I need to make sure my period is correct. So we know that the period for cosine function is usually between 0 and 2 pi. But this particular one is between 0 and 10 pi over 3. So I need to make sure, I already have the 0 that I want, but I need to get 2 pi over 3 on the right side. So to do that, I multiply by 3. I'm going to multiply by 3 because I know if I multiply, it's not going to change the left side. 3 times 0 will still be 0. So I'm multiplying by 3. So the 3's will cancel. So now we have that 3x is in between 0 and 10 pi. And notice we want 2 pi, so in order to get 2 pi, I need to divide through by 5. So now we have that 3x over 5 is between 0 and 2 pi. So now we know that 3x over 5 is my argument, or I can say 3/5. Cosine is reciprocal to the secant function, so the blue is actually y equals 5 secant of 3/5 x. Notice that wherever the x-intercept was, that's where the asymptotes were, and then we use the 3 other points to make nice curves.